Hi, my name is Tariq, and in this video, we will see the next case, the second case of the delete operation, that is deleting a node which has one child. In the last lecture, we implemented the first case for the delete operation, and now we will implement the second case, which is this one. Node has one child. So in this binary tree, we have two nodes, 20 and 90. So I will go for the 90 to delete this node. So when we will delete this node, what parameters we need to take care, we will see in this lecture. So let's start. Write the delete statement, pst.delete, and what we will delete the node number 90. All right, and then let's mark a value here, mark a breakpoint here, and here we will write our second case. Okay, so in the else if. So in the first case, we checked that if the left node of the current pointer and the right hand side node of the current pointer, these both nodes should be null. So for example, this is the leaf node, and if you want to delete this, we need to make sure that left reference and the right reference, both the references should be null. So this would make the node leaf node. This is the requirement for the leaf node. To determine that if the node is not a leaf node, we also need to determine that it only has single node. So we need to check that if the left is null or the right is null, at least one should be null. So in this case, the right hand side is null, and on the left hand side we have 75 attached to the node 90. So we will have to check if current, right? Okay, before doing this, let's mark a breakpoint at this line where our pointers are. So these 2 pointers, there would be somewhere in this tree. So let's debug this. Okay, so now our code is at line 73 and is standing here. Now let's see where the pointers are. So parent dot data is at 70. Okay, so the parent pointer is at 70, and current dot data, current pointer is at 90, right? And our boolean variable is left child is false. So now set these pointers. Let us set these pointers. This is current is at 90, and parent is at node number 70, right? And our left node is left child variable is false. How these pointers are pointing to these nodes, I have already explained this in my previous videos. So if you are watching this video before and you have skipped my last videos about the delete operation, so first go and watch those videos, and then you can understand completely. Okay, so now what we need to take care, we need to see that if either one, if left is null or the right is null, right? We need to make sure that this parent has only one child. So let's say this is case number 2, and this is delete a node having one child. Okay, and we will write else if. We will check current. Okay, the current pointer current dot right is equals to null. If the current is null, okay, if the current node is null, then what you would do, so first we will check if is this the root one, like is current point standing at the root node. So we will check if it's equals to root, because this is very possible that we have a tree and that tree only have the root node only, right? Because it's very possible. So we need to check if current is actually at the root node, and we do not have any other node except the root node. So if it is the case, then we will see root is equals to current dot left. Okay, whatever is on the left hand side. So for example, if we are standing here, on the 50, and if the current dot right, the current pointer is also here. Let's say, for to make you understand, let me point it. The right side is equals to null. So this is right side, this is null, and it means this node exists. 30 exists. So what we are saying is current dot left. This is the left. Make this a root. So 30 will become the root node, and 50 will no longer be there, right? So now this is for this case. This is for the root case, and then else if is left child. Okay, we need to check is left child, and is left child is actually false. If it is false, false, so what you would do is parent dot right. Okay, the right of the parent. Okay, parent dot right, set parent dot right to current dot left, right? So what we are doing actually is we are setting this 75 to be here. Okay, we are setting 75 to here, and this node will no longer be there, and 75 will point to the right hand side of the parent. This is parent, and this is the right hand side, and 75 will point to the right hand side of the parent, right? So this is what we want to actually accomplish. This is what we want to get. Okay, so this is the first case. And the second case is let's say we do not have this, the right hand side node, and we have a node on the right hand side. Okay, let's say we have 100. So in that case, what we would do? So in that case, we need to have another check, right? We need to have another check. So here we will write that. So we will say else if current dot left is equals to null. Okay, current dot left is equals to null. It's the same code. Then if current is equals to root, if it's the root, then what we will do, root is equals to current dot. Now this time we will assign the right hand side node will become the root node. Okay, the right hand side node will become the root node. If previously we made the left hand side node become the root node, right? But this time we will make the right hand side to be the root node. And else if is left child is equals to false. Okay, if it's equals to false, then what you would do, you will say parent dot right. Okay, so now see what we are doing actually. So this is the parent, and this is the right hand side. Now we want to move this 100 to come here. We want to move this 100 to take the place of 90. So what we will say, parent dot right will be equal to the current dot right, because this is on the right hand side. Parent dot right, this is the parent's right. Current dot right, this is the right hand side. So simply we want to move this to here. Okay, we want to move this to here. So parent dot right is equals to current dot right. Fine. So this is the actual implementation of it for the second case of delete operation. If a node has one child, then I would strongly recommend you to implement different cases. For example, if we have something on this side, okay, now in this case we saw on the right hand side, we saw the right hand side. For example, if we want to for this one, for this side, if we want to make this 20, if we want to remove this, because this is on the left hand side, right? and and the second option is, for example, if we have something here, if we have a node here, then what will be the case? There will be some changes in the code, right? There will be some changes in the code. We need to uh, we also need to handle these cases, okay, for the right hand side and for the left hand side. I've just did the demonstration for one side. So I want you to write code. I want you to think over it and then write code, debug your code, and check have you written the correct code or not. This will help you to better understand the working flow of binary search tree. So I hope this would be helpful, and I'll see you in next lecture. Thank you.